In this video we will see 3 different papers where decision tree and naive Bayes has been used. Since I was explaining the basics of decision tree and naive Bayes using the simple example, simple data, let us look at the papers which use decision tree and naive Bayes in research. So, let us look at naive Bayes first. So, these papers decision tree and naive Bayes has been used in research for long, and there are lot of publications on decision trees available. You can check internet in Google Scholar, right, but let us look at a very simple papers which is applicable here. What is the data they considered to predict the performance? So, to predict the performance they consider gender, date of birth, this is for age, specialization, its city they are from, secondary school name, status, father's job, student status as a pass or incomplete, student as that is the thing we have to predict, student status now, and the student is married or single, that is a marital status, and all the information is captured here. So, we have 1, 2, 3, 4, 5, 6, 7 features and one dependent variable to predict. So, with the sub values and they computed the frequency table like a machine computes a frequency table, then they applied a k nearest neighbor and a decision tree. Okay. Now, in a decision tree it is accurate, it is good, its performance is good, that is the example. So, it is very simple. In a student's profile information is used and not their interaction with the system, not their attendance or not the marks in midterm something. Profile information is used to predict the students will pass the exam or not. So, very simple paper, you can collect this information from survey questions and you can use that, right. So, you can check this paper how they did it. They explained decision tree in a detail, that is I gave this paper. So, just check this paper. Let us look at the next paper that is for decision tree. In this paper the used decision tree to predict the students performance, and yeah. So, the data they use is the nationality, student gender, the first language. So, what are the variables, decision variables, category variables in decision tree is also see the gender is true and nationality can be 2 or 4 and the first language is 1, 4 and teaching language, the high school percentage is like again 7. So, they have a multiple decisions to make and there are like a 1, 2, 3, 4, 5, 6, 7, 8 different features, right, or more than that. See, so previous semester marks, weeks, friends and the father's occupation, mother's occupation, qualification of the father, the student discounts, any parents working in the university, all this information has been used and they use this data to come up with a final data set. This is a final data set with the all the decisions and also they given the values in each data set, like how they distributed across these particular values has been given. So, given this data set they want to predict students performance, right. This is just a distribution of the values, they want to show how the data is distributed, this is descriptive analytics and given the table they want to predict students mark in the current semester. They used a C 4.5 decision tree algorithm with a 10-fold cross validation on data sets. The confusion matrix is shown here. Now you know what is cross validation, what is confusion matrix, because now you are using we have seen what is confusion matrix for 2 or 3 variables. Now you are able to see what is confusion matrix and you are able to make sense out of it. Excellent to excellent classification is good, 46% like a question, but recall is less because there are a lot of excellent has been classified as very good, right. So, look at that and in a C 4.5 classifier algorithm, what is the criteria to split the tree is used is information gain ratio, okay. And the maximum slice of tree should be 4, not more than that, you can say that minimal leaf size should be 1, okay. And the depth is how far the tree can grow. So, they do not want to grow tree very big or something, they want to make the trees pruning, the confidence gives the pruning criteria also. So, they used C4.5, also ID3, it is exactly same, information gain, maximum size, minimal gain, also depth also can be given, and that value is this. Okay. And CART is classification and regression tree, as I mentioned. Decision tree also can be used as regression, that is what they did. So, they applied decision tree, different decision tree algorithms, and there is a reported results here. So, this paper will help you to understand what are the features they collected, how they combine the features, how they made the decisions, how they use it to make a decision, and what are the results to compare. So, this is one paper you can read and check it out. Okay, so let us look at next paper. In this paper it has both the decision tree and naive Bayes. Okay. So, in this paper yeah. So, in this paper it is the demographic information of the like the participants, like a female, male, age, graduate students and everything, and how many students registered, how many students dropped out. So, let us see. Yep. So, this, do you remember this is the equation we saw in the naive Bayes classifier, and this also explains how naive Bayes assumption is helping you to make this Bayes theorem, and let us look at it. Yeah. So, I want to show this one thing. So, they used the decision tree, naive Bayes, nearest to neighbor, naive Bayes, nearest to neighbor, decision tree, and some neural network with 3 layers. Do not worry about that. So, naive Bayes is performed like this. Hope you understand this curve, this is ROC curve. So, naive Bayes is not good. Okay. Also, the nearest neighbor is not performed well, but decision tree performed well, but although the nearest to neighbor like a neural network might have performed well. So, I just want you to check these papers, understand what is the paper data you used, and what are the classifiers they use, how they report the results. I hope now you are able to understand the paper which bit detailed, because now you know what is algorithm, how are the metrics. So, that helps you to understand the paper, and it gives you identify the gap in the existing literature, and that might motivate you to collect data on your own, and you can write your own paper, do some own research. So, that 3 papers are given in this slide. You can download and you can check those paper details from scholar.google.com. It is all available freely. If not, put that in the forum. We can give a link where you can download that. So, there is 3 papers. So, can you list down application of decision tree and naive Bayes, and also what data is required, what are the features required, and what are the categories in the features, like what are the decision making values in the features. List down, this is based on, you know what is decision tree now, what is naive Bayes now, and you have seen 3 applications of papers. Can you list down some of the applications of decision tree in learning analytics or the data from the learning environment? So, there is no answer, it is just if you list it down, just go ahead and try collecting data if possible and apply these algorithms. If the results are good, different, and different context or different than the existing research, please publish it in a good venue, international conference or journals. So, in this week we saw what is decision tree, what is naive Bayes. You understood what is naive Bayes, and I talked about state transition some time back in the diagnostic analytics. If you can combine, if you can remember both transition and the Bayes theorem, I would request you go and check Eden Markov model. It's kind of if you know both, it's very easy to understand and very intuitive to go, and next step will be that. But that is not part of this course, that is completely optional. So, I hope you understood what is decision tree and naive Bayes. As usual, if you do not understand decision tree and naive Bayes, go and check the videos available on internet. The idea here is to you to understand what is the concept or logic intuition behind these 2 classifiers, not to understand all the mathematical or training parameters to be used in the classifiers. Thank you.